So I'm going to draw, I don't have a picture of my triangle, so I'm going to draw a picture of a triangle. There we go. A, B, C. And I said, does this look reasonable? AB is 10, BC is 20, and AC is 18. So I just didn't really pay attention too much to the measurements, and I look at this and I say, all right, AB and AC are approximately the same length, which I've got a good job of. Right, they're approximately the same length. 18 and 20, there's not too much of a difference there. But this should look much shorter because 10 is way shorter than 20. So really, I have to redraw this if I want to be more reasonable. 18 here, 20 is approximately the same length, and then this is 10. Now notice how that got shorter. So that is, I'm not doing any measurements, but at least it's more reasonable diagram than the first attempt at it. So this is little b, little a, and little c. And I want to find out what angle is going to be the smallest. The smallest angle is the one opposite the smallest side. It's angle C. So that's the one I need to find. So a squared equals b squared plus c squared minus 2bc times the cosine of a. Unfortunately, I don't want a, I want angle C. So I'm going to change my formula to reflect that. And now I'm going to input the numbers. Or no, I'm not going to input the numbers, I'm going to isolate the cosine of C. So c squared minus a squared minus b squared, moving the two squared terms over to the other side, then dividing both sides by negative 2ba. And now I've got the cosine isolated. And so I'm going to plug in my numbers. So that's 10 squared minus 20 squared minus 18 squared divided by negative 2 times 20 times 18. So I have an answer of 0.8666 repeating equals the cosine of C. So taking the inverse cos of both sides, I get angle C, which is 29.9 degrees or 30 degrees rounded to the nearest angle. So this is approximately 30 degrees.